Okay, so I am going to go over a short tutorial on doing the first simulation in Multisim. So Multisim is made by National Instruments. National Instruments is a professional program, and it's sold at a bargain price for students. So I highly recommend it. So under National Instruments, I have quite a few things. It's under the Circuit Design Suite 12.0. Now if you do a download from the internet now, I think it's on 14.0, but I have 12.0. So we want Multisim. Multiboard is a circuit board layout program. The schematics you make in Multisim can be exported to Multiboard and you can do a PC board layout. But for now we're doing Multisim. This is our schematic capture tool and a simulation tool as well. So give it a moment here to load. Okay, so we're going to put a simple circuit here and analyze it in the DC world. It's a good check of your homework, and that's what I'm asking you of your homework. So under here, under place component, and you'll have a large library here. I leave master database set, and under group, I'm going to go for, right now we're going to use basic devices and sources. Notice that you will have a lot of device categories to choose from. So let's do sources first. So under sources, I'm going to need some power sources. So if I click on power, I have an AC power. I'm just going to scroll down. Whoops. I have AC power. I could have DC power. This is a digital ground. It's also a signal ground. There's earth ground. We can even model non-ideal batteries and three-phase circuits. And these VCCs, VDDs, and VEEs, they are symbols for plus and minus voltages used oftentimes in a transistor circuit. But right now we're doing DC. So we do need a DC power. I'll say OK. And notice my cursor now is having a ghost of the DC power. When I click somewhere on the schematic, it will be placed. I'm going to place it. And then I'll come back to this menu. I also need a ground, so I'm going to put a ground on. Click OK. Oops, there's my ground. Now, I'm not going to place anything more in this category, so I'll just close it. Now I can come over here to the component and double click it, and I can change the voltage. So in this case, let's do 15 volts. So this is a DC voltage, but no DC voltages are pure, so we can put a little ripple, it's called, a little AC component on top of the DC. But right now we're just going to have a perfect DC component, so I will say OK. Now I need to place some more components, so place component. I'm just going to go to basic components, and under basic components I will just go down here to the resistor category, and you get a list of resistors all by their value, however many ohms they are. But I think it's less convenient to find the exact value that I want, and I usually just take whatever the first value that came up was. I don't know what it was, but I'm just going to pick one, any value, and put the component on. So I'm going to put 3 resistors on. 1, OK, 2, OK, 3, close. So I'm done placing the components. I don't like that. I want to make a series circuit, so this one's kind of turned the wrong way for me. If I right click on it, I can rotate it 90 degrees and make it nicer. Notice that Multisim automatically gives the reference designation, so there's an R1, R2, and R3, and you don't have to name the resistors. So let's change the values. If I want it to be 2 k ohms instead of 2 ohms, all I have to do is put a k there. If you look, you could see like a capital M is for mega, k, little k is for kilo. Then there's no units, straight ohms, and you can have milliohms too. So let's make this a 2k ohm. say OK. Let's make this one a 4K ohm. OK. These aren't, whoops, that's 4 ohms. 4K ohms. OK. And for the fun, now these I know are not real resistor values, but good enough for illustration. 246K ohms. Now I need to connect this up into a circuit. I'm going to do something here just to illustrate a point. Let's see, first of all I'm going to kind of rearrange them a little bit nicely. And then just to connect, notice how when my cursor goes over the edge of one of the components I get a dot. That's actually a node. And I can come over, click, and it connects. Start here, hold the left mouse, click, and it connects. Start here, hold the left mouse, click, and it connects. Now as I'm holding the mouse I can drive it, kind of go, I'm holding down the left mouse right now, but let's say I wanted it to go funny places. I could come over here, click, and then hold again, click, hold again, and I can continue, and I can kind of make any shapes that I want. But I don't want to do that. I just did a Control Z to get out of that. So I really want to go back and just draw it straight and pretty. Click and hold. Draw it straight. Draw it straight. Now occasionally you can't make the connection here. Let me show you what happens. I'm going to put this right up there. It automatically connected, but I want to connect the end of this resistor to this point on the circuit, and no matter what I do it doesn't want to connect there. I just can't get it to connect there. So escape key. The way you get around that when you run into it is to say place junction. Oops. You do that again. Place junction. And if I click there, I actually put a node that I can connect to. Just going to shove that up there a little bit. So I can now connect to that node because I've put a junction place there forcefully. So, alright, so now I have my circuit nice and neatly drawn. The next question will be, how do I simulate it? How do I get currents and voltages in this circuit? So the first one that I'm going to show you is the easiest one. It's just a DC operating point. It's just a probe. Later our simulations will get more complex. So under Simulate, Instruments, now I have all kinds of instruments here. I can put instruments on the circuit, but for now a simple thing that I just want to do is I want to see a measurement probe down here. So there's a measurement probe. I don't know why it wants to scroll. Let me do it again. Place, Instruments, Measurement Probe, and I'm going to put one here just by clicking, and I'm going to put one here. Whoops, I guess I have to place it again. I'm going to put one here, and for the fun of it I'm going to put one more here. Okay, so I've placed 3 measurement probes. You can see these are the things that it's going to measure. It's going to measure voltage. Peak to peak has to do with the AC or the ripple that will be on there, but we're interested in the DC. We expect any little ripple to be 0. And we're interested in the DC current. Frequency should hopefully be obviously 0. Now I can click and hold these and move them around a little bit so that they're closer to the node that they reference. So I will do that. Actually, I can select this whole circuit, move it down a little bit so I have a little bit more room. Okay, another thing that you have is you have an arrow on each one of these probe locations. The arrow indicates the direction of current flow, and that is conventional current flow like your multimeter reports, and not electron flow. So if I don't like the way this arrow is changing or oriented. So there is a reverse probe direction. If I right click on it, reverse the probe direction, and I changed my arrows around. Okay, so I have 3 measurement probes. We of course expect the current to be the same everywhere in this circuit, and to see that, now we just push this run button, run, and everything populates. So truly the voltage at this node is 15 volts. Then I lose some voltage between here and here, so at this node I've dropped down to 12.5 volts. I lose some more voltage on R2, so I've dropped down to 7.5 volts. And if I were to put a probe here, I would be back down to 0 volts. Now the simulations will not run unless you put a reference ground. So you must put a ground point somewhere in the circuit because everything else is referenced to that. I challenge you to play with it, move the ground somewhere else, and see how everything else is referenced to that point. The current, DC current, is 1.25 milliamps at all 3 nodes because it's a series circuit and there's one current everywhere. So let's stop that simulation for now. So I'm going to get rid of my probes. So later on we will do some simulations that are going to say with much more complex circuits, and you will need a node designation for each one. You know, there's a node here, a node here, and a node here, and there's 1, 2, 3, 4 branches to this circuit, and 1, 2, 3, 4 nodes to this circuit. So I want to be able to see where the nodes are because it's going to be important to me in the simulations later on. So options, I think it was under global preferences, but let's check. I forgot where it was, sorry. You can change the colors here that you want on your simulation. Okay, so it wasn't here, sorry, but I suggest you check the options there. There's one that you can change the how the components are placed that makes it more convenient. So for each, oh, here it is. So I'm on my schematic right now and it says sheet visibility. I can show the labels, reference designation values, tolerance. I can print all of this on the schematic. But the one that I want to make sure that I show is the net names. I believe that's correct. And here I can change coloring, I can change things about the workspace. Yes, okay. So it's in sheet visibility, and I believe what I want to do is show all the net names, show all. Click OK, and there they are. Okay, so I have node 1, node 2, node 3, and node 0. So later on, our simulations are going to ask us find current in node 1 or 2 or 3. But first you need to see where the automatic labeling of the nodes is. Okay, so that should get you started.